So in this example, we're going to use the fact that we know the endpoints of the diameter of a circle, and we're going to apply the midpoint formula to find the center, the midpoint between those points, which will be the center of the circle. And then we'll find the length of the radius by using the distance formula. So the first thing that I'm going to do is I'm going to draw what's called a generic circle. A generic circle is just going to be a circle. These points, I'm just going to draw a regular circle with a nice horizontal diameter. I'm going to place the center here in the middle. It looks kind of like a Pokeball, doesn't it? Anyway, so I am going to label my first point on the left and my second point on the right. Now, the reason I say this is a generic circle and that it's not drawn to scale is that if we were to look at this on an actual graph, the point -9, 0 would be to the left and down of the point 1, 6, but here it appears on the right. I'm just using it as a placeholder to remember that I have the endpoints of a diameter and that this distance between the diameter and the center is r. So it doesn't matter which of these points I use later because the length I'm going to get from my radius is going to be the same whether I go from the center to the left or from the center to the right. And so what I'm going to do is first find that center, and we need to remember that the center is equal to the midpoint between the endpoints of the diameter. I'm going to go ahead and write down the midpoint formula. That's equal to x1 plus x2 over 2. That's the sum of the x's. And the y coordinate is y1 plus y2 over 2, which is the average of the y values. It does not matter which of these I call x1 and y1 and which one I call x1 and y2, or x2 and y2, but I'm just going to go ahead and label them from left to right. Right, so what I get here is x1 plus x2 is 1 plus -9 over 2, and y1 plus y2 is 6 plus 0 over 2. If I simplify this, 1 plus -9 is -8 over 2. And on the right, 6 plus 0 is 6 over 2. And finally, simplifying this gives me that the center of my circle is going to be equal to -8 divided by 2, which is -4, comma 6 divided by 2, which is 3. I'm going to label that on my circle diagram. Now, in order to find the radius, I'm going to find the distance from that center of -4, 3 to either of my other points. The easiest point to use is probably the one that includes 0. So I'm going to use these 2 points in my distance formula. I'm going to go ahead and label these a new x1, y1, and x2, y2. These are different from the previous problem, okay? I'm actually going to use a different color. Instead of pink, let's go ahead and use turquoise. So we're going to call this x1, y1, and we're going to call -9, 0, x2, y2. And so what I'm going to get is that my distance, which is the radius, which we'll call r, is equal to the distance formula, square root of x2 minus x1 squared plus y2 minus y1 squared. And we'll be using our new blue x1, y1, and x2, y2. So when I rewrite this, I'll give myself a little more room here. I'm also going to white out this bottom because I know how this is going, okay? I know I'm going to need a little more space. No shame in that game. All right. So what we're going to do is plug in these numbers. I get that my r is equal to the square root of x2 minus x1. That is -9 minus -4. Squared plus y2 minus y1, which is 0 minus 6, or I'm sorry, 0 minus 3 squared. When I simplify this, negative 9 minus negative 4 is the same as negative 9 plus 4, which is negative 5. Plus 0 minus 3 is negative 3, and we square that as well. So r is equal to the square root of negative 5 squared, which is 25, plus negative 3 squared, which is 9. When I add those together, I get 34. So my radius is equal to the square root of 34. This is our exact answer. And on Lumen, it's going to want you to give the exact answer. Now, 34 is equal to 17 times 2. Both of those are prime numbers, so I don't need to worry about simplifying this radical because there's no square factors contained within 34. I'm going to erase off my factor tree. But then I am going to say that we could get a decimal approximation. Before I pull out the calculator, let's just think about this. I know some square numbers, and I know that 6 times 6 is 36, and 5 times 5 is 25. So the square root of 34 is really close to the square root of 36. It's close to 6, but it's not quite there. And it's more than 5. So it's probably going to be a high decimal in the 5s, so 5.8 or so. So let me go ahead and pull this over here, and I'll use my Desmos calculator. I'm going to click the square root button, but you could also type in the little letters SQRT, and it would automatically generate. It's about 5.83, so that's cool. So R is approximately equal to 5.83, and this is what we call the decimal approximation. Or the approximate answer. And I use my squiggly equals here because it is approximately equal to, not exactly equal to.